Hey everyone, I want to take a moment and just discuss the last question that we had on the sample test. I think that's going to be the longest question that you'd have on the module 2 test. And question 7 read, a company makes 4 products that have the following characteristics. Product A sells for $50 but needs $10 of materials and $15 of labor to produce. Product B sells for $75 but needs $30 of material, $15 of labor to produce. Product C sells for $100 and needs $50 of material, $30 of labor to produce. And then finally, product D sells for $150 but needs $75 of material and $40 of labor to produce. The processing requirements for each product, each of the 4 machines is shown in the table below. Okay, so whenever you get this question, you know that you're being asked for, it's kind of like a priority ordering situation where you're trying to figure out which of these different products here should we make and in what order should we make them, okay? And it's typically going to boil down to which one gives us the most profit. Okay, so if B makes the most profit, we're going to try and make as much of B before we move on to A, maybe C or D, okay? And the 2 approaches to doing this, you're either going to be asked to calculate this using the traditional approach or what we call the bottleneck approach. Okay. Now, the traditional approach just basically looks to see which one gives you the greatest contribution. Go ahead and make that. Okay. The bottleneck approach looks at what's the amount of contribution that we would get at the bottleneck workstation, right? So if the bottleneck workstation takes 5 minutes to process one part, I'll divide my profit contribution by the amount of time it takes at bottleneck. Okay. So let's see what type of questions we have with this right here. Work centers W, X, Y, and Z are available for 40 hours a week and have no setup time when switching between products. Market demand for each product is 80 units per week. Okay, so they need to make 80 units for A, 80 units for B, 80 units for C, 80 units for D. In the questions that follow, the traditional method refers to maximizing the contribution margin per unit for each product, and the bottleneck method refers to maximizing the contribution margin per minute at the bottleneck. Okay. So using the information above, which workstation is of greatest concern? Okay, so this question here is asking us what is of greatest concern. Okay, so in your mind, that should translate to which workstation is your bottleneck. Okay, so let's go ahead and figure out what station is the bottleneck. And I'm going to take this data and I'm just going to paste it down here. And I want to put a row with my demand information. We're told that there's a demand for 80 units of A, 80 units of B, 80 units of C, 80 units of D. Okay. And I need to also figure out how much time will I need to make each and every one of these. Okay. So let's see. Why is this typing here? Time. Something's off. Okay, it's not letting me type and wonder why. Let's try it a different way. So I need to know what the amount of time needed to make all these products at a different workstation. Okay. And what's a unit of time that we have in this question? We're told that they have 40 hours available each week. Okay. So we have 40 hours available, and we've been told how many minutes it takes to make product A at workstation W, and so on and so forth. Okay. So I have time available is equal to 40 hours, but I need to convert that into minutes. So 40 hours equals to 40 times 60 minutes every hour. So every week we have 2,400 minutes available. Okay. But the amount of time I need to make everything that I need to make here will be linked to how many units I need to make. Okay, so for example, product A takes 6 minutes to make one part of the workstation W. So the amount of time I need here will be a combination of how much time is needed at this workstation multiplied by the total demand, right? So 6 minutes for product A multiplied by 80 plus 1 minute for B multiplied by 80 and so on and so forth. Okay. You could use a sum product function for this, sum product, and just multiply these 4 values here by the corresponding demand. Okay. And I'm going to hold the demand values constant. This is where I add those dollar signs by hitting F4 on your keyboard. And I do that so that I can drag down my formulation. Okay. So now I have my time needed, my time available. I can go ahead and look to see if there are any of them that exceed the amount of time available. Okay. And looking at these values, it's only this one value right here. This is greater than the amount of time available. So I know that our workstation WX here, is going to be our bottleneck. Okay. Your bottleneck is that workstation that has the highest amount of time requirement. Okay. So to answer that first question, which workstation is of greatest concern? My workstation of greatest concern is workstation X. I don't have enough time to make everything on that workstation, so I need to work my way around this workstation. Okay. The next question is, using the traditional method, which product should be scheduled first? Okay. So I know how much time I need to make everything here. I now need to figure out which of these 4 products should we make first. Okay. So to me to figure that out, I need to figure out what's my profit contribution for every product. Okay. We have our demand. I need to know what's the price that we're going to be selling this product at. I need to know what are the costs, total costs or variable costs associated with all this product. I need to then use that to calculate my profit contribution. Okay. Now, once I know how much each product gives me in terms of profit, then I can go ahead and say, hey, on the basis of this, my order of production will be maybe B to C to A to D. Okay. So let's try and get these pieces of information in here. Let's start with the price that's given to you in the question. A sells for $50, B sells for $75, C sells for $100, and D sells for $150. So 50, 75, 100, 150. 50, 75, 100, 150. This is how much we're selling this product at if we are to be selling them on the market. Then we add our cost information. A has total cost of $10 for materials, $50 for labor. That's $25 total. B has, going back and forth. B has $30 for material, $15, so that's $45 for B. And then for C, we have 80, 45 and 80. And then finally for D, $75 for material and $40 for labor. So that adds up to 105. Okay. So now that we have our price that we're selling the product at and we have our costs, if I get the difference between these two, it tells me our profit contribution, right? So A is 50 minus 25. My profit contribution here is $25. For B, it's $30. For C, it's $20, and finally for D, we have a contribution of 45. So now I can go ahead and see which one has the highest contribution. Remember, this is kind of like a profit. Okay, so the highest contribution here is going to be D. So this goes first, followed by B. This goes second, followed by A. This goes third. And finally, we'll finish off with product C. This will be fourth. Okay. Now, does this answer the question? Which product should be scheduled first? I'm going to say let's schedule D first, because that has the highest profit contribution. Okay. All right. So that would answer that. And then if ever you get a question asking you to show how this would differ with, say, the bottleneck approach, you could take this table here, copy this, and let's paste it down here. I already have this here, bottleneck. Okay. Now with the bottleneck approach, everything here stays the same until it gets to our calculation of the contribution. Okay. Now for us to figure out which product has the highest contribution at the bottleneck, I need to add a column right here. And this column that this row that I'm going to add here is called the time at the bottleneck. Okay. So my bottleneck workstation was this one right here. Okay. My time for product A at the bottleneck is 9 minutes. For B, it's 10 minutes. For C, it's 4 minutes. And for D, it's 8 minutes. Okay. So now that I know that, let's add yet another row and say, what's our contribution per minute at the bottleneck? Okay. So the contribution divided by the time at the bottleneck gives us a new value. And this is going to be equal to 25 divided by 9. Okay, I get $2.78. For B, it's $3. And then $5 for C. And for D, we have $5.63. Okay, so that then determines the ordering of production. I again look to see which one has the highest contribution per minute. And this is going to go first. We're going to start off with D, then move on to C. This is going to go second. Then from C, we move to B. This is going to go third. And we finish up with A. This is fourth. Okay, so you notice here that the order of production differs. Okay, so now typically the last question that you might get here is, I might ask you to, say with the traditional method or the bottleneck method, figure out how many units of each can be produced. Okay. Now I know I need to make 80 units of each because our demand is 80, 80, 80, 80. Okay. With the traditional approach, we said that we should first of all make product D. Okay. So I'm going to go ahead and schedule product D and figure out how much time do we have after making D. Okay. So we start the week off with 2,400 minutes. And I need to figure out how much time will I have if I make all 80 units of D. Okay. So this means that I'm going to deduct from the time we have available the amount of time it takes to make 1 unit of D, multiplied by how many total number of units we need to make, which is 80. That's the demand that you have down there. Okay. So after we make all 80 units of D, we are we have all positive numbers here, so that tells me we had enough time to make all 80 units of D. I then move on to the next product, which our second priority here is B, and ask how much time will we have left over after making B. Okay, so here again, we start off with 1440 minutes left over here. Let's subtract the amount of time it needed to make 1 unit of B, but multiplying that by the number of total demand, which is 80 units. And we're down to 1360 units, 1360 minutes here. Again, there's no negative value here, so I know we had more than enough time to make all 80 units of B. Okay, then I move on to my third priority, which is product A, and ask myself how much time will we have left over after making all of A. Okay, so now I start with 1360 minutes here and subtract the amount of time needed to make 80 units of A, which is 6 minutes multiplied by 80. And that brings me down to 880 minutes here. Again, so far there's no negative values here, so I know we've made everything we need to make. Okay. And then I move on to our very last product, which is our fourth priority with C. So I need to see how much time after C. And the time after C here will be, we start off with 880 minutes minus the amount of time it's needed to make 80 units of C, which is 3 minutes per unit, multiplied by 80. And then come down to 640 minutes here. But I run into a negative right here. Okay. Now this negative here tells me that we don't have enough time to make all 80 units of C. So I have to ask myself, how many units then can we make in 240 minutes? Because that's how much time we had left over. So if it takes 4 minutes to make 1 unit, and we have 240 minutes left over, then it'll be 240 divided by 4. We only have, we can only make 60 units of product C. Okay, so I'm going to adjust my numbers here and say time after making 60 units of C, not 80. So this value here will not be 80. We'll change this to 60. Okay, so keep that in mind. So let's repeat this. So this would equal 880 minus 3 multiplied by 60, because we only have enough time to make 60 units of product. Okay. And now we don't have any negatives. We're down to no time left over at workstation X here, but that's basically all I wanted to see. Okay. So that completes the calculations for how much product can we actually make. So we go ahead and say we can only make 60 units of product C. Okay. So that would be all that I would need for this type of problem. Okay. And you'd repeat the same with the bottleneck workstation approach. Just make sure that you have your different headings in place, the time after A, after B, after C, and all that. Okay. So that's what I wanted to share with this question. Now, let me see what other questions we might have missed. Okay, throughput questions are very straightforward. Question 6 is about throughput. The figure above shows the process for paying tuition at a major university. And the first question here was, what's the throughput time for ABC? Throughput time is just how much time would a student take if they walked in and started off at workstation A, went to B next, then went to C, then finished off at workstation E. The total amount of time is the time given in parentheses here. So this would equal 2 plus 5 plus 6 plus 4. Okay, so they spend a total of 17 minutes if they chose this route. The next question is what's the throughput for the ABD? So again, be 2 plus 5 plus 10 plus 4. So that would be 7 plus 10 is 17. 17 plus 4, that's going to be 21 minutes. Okay. What is the capacity for the ABCE route? ABCE. Now, keep in mind here that your capacity is limited by the bottleneck workstation. Okay, so your task here would be to figure out what's your bottleneck workstation. Okay, your bottleneck workstation is the slowest link within whatever series of activities that you have in your table here, in your chart. So for ABCE, I see that C takes 6 minutes per student. That's the longest amount of time I see there. So that becomes my bottleneck workstation, because if it takes 6 minutes per student, then it means in every hour, if an hour has 60 minutes, you can only serve 60 divided by 6, you can only serve 10 students. Okay, so that is your capacity. The capacity will be 10 students for that specific path. Okay, and the last question here is, if 60% of the students are routed to C, 40 routed to D, what's the average capacity per hour? Okay, now let's look at that. We already have the capacity for the ABCE route. I need, this is ABCE. I need to get the ABDE capacity. Again, I need to figure out what's my bottleneck workstation. Okay, and the one that takes the longest amount of time is this right here, 10. Okay, so since 10 is the longest amount of time taken, I want to figure out how many students can actually be served along that path. Okay, so this is, in 1 hour, we have 60 minutes. Divide that by 10, we can serve 6 students here. Okay. Now, this question here is saying if 60% of the students are routed to C, 40% are routed to D, what's the average capacity? So I'll multiply the 10 by 60%, and then I'll add that to 6 multiplied by 40%. Okay, so multiply this value by this percentage, and then add it to 6 multiplied by 40. So this will be 10 multiplied by 60, which is 6. And then I have 6 students multiplied by 40%. It's 2.4. And if I add these two up, if I sum these up, I get my average capacity, which is 8.4 students. Okay, so this is the solution to the last question that we have on here. 8.4 students, 8.4 students. Okay, and you can leave it to the decimal point, that's fine. Okay, all right, so that answers the last question that I had here. Everything else was stuff we covered in class. So I'm going to go ahead and stop right here.